Well, before I erase the board from the previous example, I wanted to make one thing very clear. We had this set, the collection of UX's, where X is any real number, and we determined that this was a cover for R. It's uncountable because the number of sets here is uncountable. There's one for each element of the real line. And then we determined that this, when we change X being in the real numbers to just using the rational numbers, we found a countable subcover of R. And we argued then that there would be no finite finite subcover. Well, let's just change this problem a little bit. Instead of making my capital set, my capital E, the set in the definition, instead of making that R, let's make it this. Let's make capital E the closed interval from 0 to 1. Let's define for every single X, there's an uncountable number of X's in this interval. Let's define UX to be exactly the same thing as we did up here. So, for example, U0 would be, actually these would be, U0 is going to be the open interval, 0 plus or minus 0.001, which is this. U.5 in the middle of the interval would be 0.5 plus or minus 0.001. So obviously if we union all of those together, all of the sets UX, where X is in between the closed intervals 0 to 1, we would get this. If you union them all together, the union of the UX's where X is chosen to be from 0 to 1 in that closed interval, it would go all the way to from 0 to the left 0.001 to up to 1 to the right 0.001. Let's see, did I do that correctly? They were open intervals, so this should be an open interval. We're unioning together all of those open intervals. But this closed interval is completely contained inside this, the union of all those U sub x's. Therefore, we have an uncountable cover for this. So, well, like we just said here. Now, is there a finite subcover for that? Well, in fact, there is. If I let's see, I think this is a capital lambda, equal the set 0, 0.001, 0.002, go all the way up to 0.999 and 1.0. So this set looks like it would have about 1,001 elements, since we've got the 0 element in there as well. But notice that the union of the UX's, where X, the index set is simply this, X is an element of lambda, capital lambda. If we union all of those together, we're going to get exactly the same thing. We're going to get this. Negative 0.001 to 1.001. Obviously, since it's the same union, this will also cover the closed interval from 0 to 1. And we have a finite subcover. Let that, and let's say U sub x, it's a collection of sets where X is taken from this lambda, is a finite subcover. Of our set E, which for this problem was the interval from 0 to 1. Okay, it's finite because it has a finite number of elements. This has exactly, precisely 1,001 sets that are being unioned together. And it's a subcover because these sets are, this collection of sets is a subset of this collection of sets, u of x defined for all x in 0 to 1. So we found a finite subcover, and let's see, did we prove that every open cover will have a finite subcover? No, we didn't. But in fact, for this set, every open cover will have a finite subcover. We'll see that in just a few minutes. And therefore, this is a compact set.